For an object doing circular motion, we can describe such an object with so-called angular displacement. So here is the picture to show you the object's motion. Let's say this object is moving along this circular path, and right now it's moving counterclockwise. So that's the angular velocity omega. It's going counterclockwise. And how to describe this angular velocity? So we want to build a coordinate system that has a starting position for the object. Let's suppose that this direction is the x-axis, and the center here, O, is the origin. The object right now is at this position, this location. So that's the position vector r. So we can describe such a motion with x and y coordinate system, but it's not very convenient since the object is following this path. So it's effectively a one-dimensional motion. This means that we do not actually need two coordinates such as x and y to describe this object motion. We just need one single variable, and that variable in this picture is given by this angle. Let's call it theta. Okay, so theta is the angular displacement of this object, combined with the condition that the object has a distance r to the center. Then we can totally determine the position of the object. Okay, so now how do I calculate the angular velocity? So angular velocity is given by the derivative of theta with respect to time. Okay, and in this case, omega is going counterclockwise. So the definition is that this direction is a positive direction. So the angle theta here, the angular displacement theta is also positive, and the theta dt is also positive. So that's the counterclockwise direction. Now if another object, let's say, is moving along the opposite direction, this direction, omega, let's say omega prime, and its angle with the x-axis is this angle theta prime. Okay. Then the definition is that this theta prime is negative. So previously theta is positive, and omega prime equals d theta prime dt is also negative since it's clockwise. So how to understand this counterclockwise as being positive and clockwise as being negative? Let's build the coordinate system, Cartesian coordinate system on this plane here. So that's the x-axis, that's the y-axis, and the Cartesian coordinate system obeys the right-hand rule. So the z-axis is given by a direction going out of the screen right now, pointing toward the audience, and that is the z direction. So how to determine the direction of this angle or the angular velocity? So the angle here, since it's counterclockwise, we also use right-hand rule. So again, let me write down here, right hand rule. So your finger is curled along this theta direction. Now the thumb is pointing toward the audience, so it's going out of the screen. So that direction is the z direction. So according to right-hand rule, theta is along positive z direction, which is why is positive. Now if we do the same thing for omega using right-hand rule, the fingers of the right hand is curling along this direction. Now the thumb is pointing toward the z-axis. Omega is along positive z-axis, so that's why omega is positive. So that's for counterclockwise. Now for clockwise rotation or circular motion, use right hand rule, we can see theta prime is along negative z direction, which is why theta prime is negative. And omega prime is again along negative z direction, so omega prime is also negative.